All right, ladies and gentlemen, this is the Test 2 review. So I'm very excited to be bringing you this review today. This review will contain all the information you need to be successful on your second major algebra test of the year. So we're going to begin with a review of this term here, the additive inverse, ADDITIVE. Additive Inverse, INVERSE. So there's an example and there's a rule. Here's the example. The example is -4 plus 4 equals 0. The additive inverse of -4 is +4. The sum of -4 and +4 is 0. So here's the rule. The sum of an addend and its inverse, its additive inverse, is always 0. We're learning this for a reason. The reason we're learning this is because this is one of your tools. When I worked in HVAC, my main tools were a cordless power drill and a Sawzall. Have y'all ever seen one of those? It is an incredibly fun machine to use. It was a wireless power saw. It was amazing. I felt like I was a mech warrior with that thing. What's that? It's super awesome. Yeah. Okay, well, just like we have tools in trade work, we have tools in algebra. This additive inverse is a tool, so I'd like to show you when you use that tool. So here's an algebra example. Here's an Algebra 1 example. X plus 6 equals 9. Solve for x. What you do to get x by itself is you use the additive inverse of this number. What's the additive inverse of +6? -6. Now we balance it by putting it on both sides. Remember. Now what? X. Yeah. So additive inverses cancel to 0. So we can always strike that. And then we have this equal to 9 minus 6, which is 3. This was the subtraction property of equality. And this was simplification. Do you understand? Now let's do one more additive inverse example. x minus 2/3 equals 4/3. Remember, apply the additive inverse of the number and do it on both sides. So what's the additive inverse of my number in this case? Yeah, positive 2/3. And I want to be in balance, so I'm going to do that too. Both sides. Let's make sure we remember how to add fractions. We can strike this one on the left. These are additive inverses, so they cancel. Remember, with fractions, when you add, you first check to make sure that you have a common denominator. Do we have a common denominator? So when we have a common denominator, you only have to add the numerators. So this would be 4 plus 2, which is what? Over. Can I reduce that fraction to what? X equals 2. So the answer in this case is x equals 2. The answer in this case was x equals 3. What's that? I'm not making you do that check part right now, okay? Because I'm trying to keep us focused on this inverse thing. Okay, so do we understand when you have an x or some letter and then some plus or minus symbol and then some number, could be a fraction, all you do to get x by itself is you drop that additive inverse, whether it's positive or negative, okay? This number will determine whether you're going to do plus or minus. And then that gets rid of the number. So x is by itself, but you just have to do it to both sides. Do you understand? Yeah? Okay. So that was the additive inverse. Now we're going to move on to our multiplicative inverse. M-U-L-T-I-P, L-I-C-A-T-I-V-E. Multiplicative inverse, aka also known as the reciprocal. The multiplicative inverse, also known as the reciprocal. Harley, sometimes I'll say, tell me the multiplicative inverse. What I mean is, tell me the reciprocal. Didi, if I ask you for the reciprocal, you could reply by saying the multiplicative inverse is, because these are just two different ways to say the same thing, okay? It's just that saying multiplicative inverse over and over again gets a little tiring, so this is a little easier to say. Just like before, I want to do examples, and then I want to talk about the rule. But in this case, I want to do a table. So I want you to make a table where you've got 3 columns. First column says original. Second column says reciprocal. Third column says product. Mm-hmm. Yep. Original reciprocal product. So here's an original. What's the reciprocal? Remember what Giselle said. Just flip it, right? Just flip it. So we do 5 over 1. Correct. Can we reduce 5 over 1? What is that? It's just 5, right? On the test tomorrow, I'll accept either 5 over 1 or 5. Let's try another example. What's the reciprocal of 2 over 3? 3 over 2. Good. How about 2x? Let me hold off on that. Let me hold off on that for just a second. I forgot to. Let me just try 8. What's the reciprocal of 8? 1 over 8. Now, the reason that that's the reciprocal of 8 is because 8 is equal to 8 over 1. And so the reciprocal is 1 over 8. Good. Let me make sure you've got these whole numbers down. How about negative 12? What's the reciprocal? One over negative 12. When we write so this is equal to negative 12 over 1. And then, was it Curtis? Curtis flipped it. And so he said 1 over negative 12. In mathematics, that negative sign can either hang out here up in front of the fraction, or it goes with the numerator. Okay? But I want you to make sure that you understand that negative doesn't just hang out down here in the denominator only. It actually is probably a better idea to always put it up here. That way you don't mess up. But it doesn't really matter. Okay, now I'm going to do my example. How about 2x? Yeah, who said it? What'd you say? 1 over 2x is correct. So Cameron got it right. So Cameron, you're getting the idea. He just said, well, 2x is like 2x over 1. Flip it. It's got to be 1 over 2x. Now I want to do something what's called absurd. Absurd means I'm going to make something ridiculous. 4x to the 9th power minus 2x squared over 9. What's the reciprocal? Mm-hmm. Finally, 5 open parentheses x plus 3 close parentheses. What is the reciprocal of this expression? 1 over 5 open parentheses x plus 3. There are, Miss Moore, there's a number of people in this room who clearly got this. You guys take whatever it is, flip it, okay? Just flip it. Don't think too much about it. Now, let's go back up here and let's fill out this third column. So I'm going to erase this for a second just to make a point. What we're going to do now is we're going to multiply the original by the reciprocal. And we're going to see what we get. Remember when you're multiplying fractions, you multiply the top and then you multiply the bottom? So what's 1 over 5 times 5 over 1? Okay, so yes, you're correct. Shannon? Was it Shannon? Who was that said? Oh, okay. Joey? Was that you? No, Jose said it? Okay. So I heard 5 over 5, which is correct, but what does that reduce to? 1 over 1, which reduces to just 1. Okay, good. How about 2 over 3 times 3 over 2? 6 over 6, which is equal to 1 over 1, which is equal to 1. Nice. How about I make it hard? 8 times 1 over 8. Yeah, so we remember we just kind of put a, so now it's 8 over 8 equals 1. So remember, if you have a whole number, just put a line and a 1 so it looks like a fraction. It will keep your head clear. Like here, okay? So let's do this one. Negative 12. So we're going to have negative 12 times negative 1, which equals, which equals positive 12 over 1 times 12, which is 12, and that reduces down to 1 over 1, or just, what's the pattern here? They're all equal to 1. Okay, so let's see how quickly you can tell me. If I multiply 2x times 1 over 2x, what's the answer? Just 1. Okay, look here. Let's make sure we got this. So 2x over 1 times 1 over 2x equals 2x over 2x. The same thing divided by itself cancels down, and you get 1 over 1, or just 1. How about 4x to the ninth minus 2x squared over 9 times 9 over 4x to the ninth minus 2x squared? 1. You're done. You don't even have to think about it, right? How about this one? What's this? 1. So what's the rule? The rule is 1. Here's the rule. Let's write this out. Thank you. The rule is, thank you so much. That makes, honestly, that makes me feel good that y'all said that. Multiplying anything by its reciprocal gives 1 as the product. Always. Okay? So now, ladies and gentlemen, we're going to take a few minutes to we have 7 examples that we're going to run through very quickly, where we're going to call these algebra examples. Okay, so remember before when we were doing additive inverse, we had algebra examples. So here's Alg 1, example 1. Okay, Alg 1, example 1. We're going to apply the multiplicative inverse rule. And here's your example. And for all of these, we're going to try to solve for the letter. Here it is. 3 equals 1 over 9x. Yes. So I want to get rid of the 1 over 9 because I want x to be by itself. Remember, x is a sociopath. X is a loner. Okay. Hashtag forever alone, x. So multiply 1 over 9 by the reciprocal of 1 over 9. 9 over 1. Multiply on, but I got to do it on both sides. So this is what I do. I draw a line under the 3 and put a 1 there. That keeps my head together. Let's work on the right side first. Do I have a number multiplied by its reciprocal? What does it equal? 1. The way we show that mathematically is we just go cancel, 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 cancel. Everything cancels. And then this x, he just comes out. That's all that's left. And so we put x over here equals. Now I just multiply 9 times 3 over 1 times 1. What's that? Yeah, 27. So this is the answer to the question. All right, we're going to do several more examples, so you guys are going to have a chance to really get this. Here's Algebra 1, x2, example 2. And we're going to write down 7 equal to 1 over 4x. Can anybody tell me the answer in their head? 28. Shannon, did you see that? Jose? So what they did, guys, is they just went 4 times 7. Boom. All right. 4 times 7 divided by 1. Let's show the work, though, okay? So that was just a little fun. We multiply by the reciprocal. Oops, I'm doing the other problem. We multiply by the reciprocal of 1 over 4. We know that these all cancel out, leaving x by itself. So I have x equal to 4 times 7, which is 28. So at this point, I want to write down a rule. Let me just scroll up here. Oh, wait. I have it on my on the other page. I wrote this rule down, and I want you guys to write it down. This is the big idea. Okay, here's that question. The first question, 3 equals 1 over 9x. This, I'm going to write this again, guys, but just look. This 1 over 9, that is called the coefficient. This yellow word, coefficient. Coefficient means the number to the left of the letter. The letter is called a variable. The number is called the coefficient. Harley, I'm going to jump. Don't worry, I'm going to write this all again. So here I'm going to say this is a big idea, and I'm going to use my universe font. This is a big idea. Okay. To get rid of the number, aka the coefficient, in front of the letter, multiply both sides by the reciprocal of the coefficient. We want to get rid of the number because we want x by itself. This was my big idea. Let me put it in the special order. And we'll continue with our examples here as you guys write that down. And I want you to kind of keep that in mind as we do this next example. Yeah. The letter is the variable. And it's a good that you say that. I'm going to write up here variable. Okay, here comes our next example. What is this? Algebra example 3? Algebra 1, EX3. 5 equals 1 over 6x. What is the coefficient of the variable? 1 over 6. So multiply both sides by the reciprocal of the coefficient. Times 6 over 1. Yep. Good job. Good job, Cameron. Okay. So these all cancel over here. X equals 6 times 5, which is 30. Okay, here comes example 4. I want to show you guys something. 9 equals x over 6. This happens a lot. You start to get this idea and you say, okay, I get it. I want to multiply by the reciprocal of the coefficient. And then somebody throws this at you and you say, there is no coefficient. But there is a coefficient. I got to tell you guys, I wish they would pick a structure and stick to it, but math is. So let's rewrite this as 9 equals 1 over 6x. So this is a big idea as well. This and this is the same thing. Okay, but when we have this second way of writing it, it makes it super clear what we're supposed to do. I'm going to multiply by the reciprocal of the coefficient. So multiply by 6 over 1 on both sides. Everything on the right side cancels except the letter. X equals 54. Good. Now I'd like to end with one example of the other thing that we've been learning. Because you are going to see some of these problems. How do I solve this problem? The D word, distribute property. 3 times 8 is 24. 3 times A is 3A. So it's 24 plus 3A equals 9. Now use the additive inverse law to get rid of this 24. Minus 24 on both sides. On the left side, this cancels, and I have 3A. And what's 9 minus 24? negative 15. Now what do I do? Divide by 3 on both sides. A equals negative 5. Great job, guys. Thank you so much for joining in. Hope you learned something today. Good luck on your test tomorrow.